Hello everyone, this is teacher Rejil. This lesson is about set notations and descriptions. Our competency is illustrate well-defined sets, subsets, universal sets, null sets, and cardinality of sets. A set is a collection of elements. The elements that make up a set can be any kinds of things: letters, numbers, people, geometrical shapes, or even other sets. It can be represented in 1. Roster notation, 2. Set builder, or 3. Verbal description. First, let's talk about roster notation or listing method. Sets are named using capital letters. We have here an example. A equals 1, 2, 3, 4. These numbers 1, 2, 3, and 4 separated by commas are called the elements of set A. Notice here that these numbers are enclosed in braces. Now we can say that this one is an element of A, 2 is an element of A, 3 is an element of A, and 4 is an element of A. But 5 is not an element of A. The number of elements in A is called the cardinal number of A, or cardinality of A. This is our notation. Small letter n, and then enclosed in parentheses A, which is the name of our set, equals 4. Why 4? Because this set has 4 elements. We also have sets that have infinite number of elements. Example, B equals 2, 4, 6, 8, then dot, dot, dot. So we call this one ellipsis. This means that there are other elements that are not directly seen in our notation. So this implies that we are going to continue the pattern. 2, 4, 6, 8, then 10, 12, 14, 16, 18, and so on. So we call this one infinite set. We also have sets that have no element. Example, C equals, there's nothing. So this is the other notation. We call this one empty set or null set. Now let's talk about equal sets. Suppose A equals LOVE and B equals OVLE. Notice that the two sets contain exactly the same elements. So in this case, we say that A equals B. The two sets are equal. We also have disjoint sets. Okay? Suppose A equals YOU and B equals ME. Notice that they do not have any common element. So these two sets are called disjoint sets. We also have equivalent sets. Okay? Suppose we have A equals 2, 4, 6, 8 and B equals HOPE. Notice that they have the same number of elements. Because they have the same number of elements, we say that A is equivalent to B. This is our notation. Now, let us illustrate subset. Suppose A equals REMINT and B equals DIRMEN. Notice that every element in A is also an element in B. So in this case, we say that A is a subset of B. And we have a line under here. This means also that A is equal to B because they have exactly the same elements. Now let's define proper subset. Suppose we have A equals MINT and B equals REMINT. Okay, notice here that every element in A is also an element in B. But B contains at least one element not found in A. As a matter of fact, there are exactly two elements in B that are not found in A. So therefore, we can say that A is a proper subset of B. And if we are going to switch the elements, okay, the elements of A are REMINT and the elements of B are MIND, we can say this time that A is not a subset of B. So let's illustrate universal set. Universal set U is a set which has elements of all the related sets without repetition of elements. Okay, suppose we have here set A 1, 2, 3, 4, 5, set B 2, 4, 6, 8, 10, set C 5, 10, 15, 20. What does the universal set look like? So our universal set looks like this. So the elements are 1, 2, 3, 4, 5, 6, 8, 10, 15, 20. These are the elements, okay, that we find in A, B, and C without repeating any element. Now let's talk about set builder notation. So we have here example number 1. So this is read as B is the set of all x's such that x is an odd integer between 1 and 10. So if we are going to create a roster notation for this, okay, this is the roster notation. B equals 3, 5, 7, 9. Odd integer between 1 and 10. Example 2. C is the set of all x's such that x is a letter in the word interest. So this is the roster notation. C equals INTERS. So these letters come from the word interest without repeating a letter. Third, let's talk about verbal description method. So we have here a verbal description of our set, the set of odd numbers greater than 11. So this is our roster notation. A equals 13, 15, 17, 19, ... So greater than 11 from 13 up. Okay, example number 2. The set of even integers between 10 and 20. This is our roster notation. A equals 12, 14, 16, 18. Now I prepared here 4 items. Identify the well-defined sets and create roster notation. Okay, number 1, the set of 3-digit positive even integers. 2, A is the set of all x's such that x is an important number. Number 3, the set of outstanding students. Number 4, B is the set of all x's such that x is a positive multiple of 4 that is less than 20. You can pause the video and try working on these 4 items. If you are done, I can now show you the answer. Number 1, A equals 100, 102, 104, 106, ... Number 2 is not a well-defined set. Number 3, not well-defined set either. Then number 4, B equals 4, 8, 12, 16. Did you get all the items right? I hope you did. Thanks for watching, guys. This is Teacher Rejil. Keep safe.